ninth chapter, probability. This chapter belongs to Mathematics 2A, part 2. Last part completed introduction of the probability, definition of the probability, different types of definitions, mutually exclusive and mutually exhaustive and equally likely events, impossible and possible events. These are definitions completed last part 1. Today discuss exercise 9A problems. What is the first problem? In the experiment of throwing a die. Here which experiment is there? Here which experiment is coming? Throwing a die. Here which experiment is there? Throwing a die. Considering the following events. If throwing a die, if die is throwing, total sample space is 1, 2, 3, 4, 5, 6. Total number of possible outcomes is 6 possible outcomes. 1, 2, 3, 4, 5, 6. This is any one die throwing. Total number of possible outcomes is 6. In these 6 outcomes, you have the first problem. 3 events are given. What is the first event? First event is A equal to 1, 2, 3. Second event B is equal to 2, 4, 6. Third event C is equal to 1, 2, 3. This die is throwing. 3 events are right now. These 3 events are equally likely events are not checked. Equally likely events are nothing but the events having equal number of elements. That events are called equally likely events. If any event number of elements are equal or the probability of each event is equal, that is also be called equally likely events. Both are correct. First of all, in this A event having how many number of events? 3 number of events. B having how many number of events? B also be 3 number of events. Here C event having number of elements is what? Number of elements here also be 3. Here these all events having equal number of possible outcomes. That's why this A, B, C are equally likely events. Which events? Equally likely events. This is the definition of equally likely. Nothing but if any events are equally likely, the probability of all events having same or equal, or the events having equal number of elements, both are similar. This is the first one. What is the second one? Second one, A is equal to 1, 3, 5. B is equal to 2, 4. C is equal to 6. Are these events mutually exclusive events? Mutually exclusive events, nothing but 2 events having no common elements. That elements are called mutually exclusive events. Here first you can find A intersection B. Common elements. What is the common elements of these two? No common elements. That is nothing but 5. Correct understand? Similarly, the intersection of B intersection C. The common elements of B and C. B and C having no common elements. That is also B 5. The intersection of C and A. This C and A intersection nothing but common elements. How many common elements? No common element. That is 5. That's why here A, B are mutually exclusive. B and C are mutually exclusive. C and A also be mutually exclusive. Then A, B, C. 3 events are. These 3 events are mutually exclusive events. Why? Because the common elements of any 2 events having no common elements. This is a very important. By using definition, you can solve this problem. Next, third one. These 3 events are mutually exclusive. Next, third one. A value is 2, 3, 4, 6. B value is 3, 6. C value is 1, 5, 6. Are these events are exhaustive events or not? Exhaustive nothing but the union of all events equal to sample space. What is the sample space of one die is throwing? What is the sample space? Sample space is 1 comma 2 comma 3 comma 5 comma 6. Number of sample space value is 6. Here, first you can write A union B union C. The combined elements of these are what? 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 also is there. 1, 2, 3, 4, 5, 6. The combination of these three events is 1 comma 2 comma 3 comma 5 comma 6. This is the equal to sample space. The combination of all events, the combined of all events equal to sample space. That events are called exhaustive events. That event are called exhaustive events. Understood or not, friends? Equally likely nothing but events having number of elements equal to equal. Next, exclusive events. The common elements of any two events are no common elements, nothing but that value equal to pi. Exhaustive events, nothing but the combination of all events is equal to sample space. This is the exhaustive and exclusive and equally likely events problem and definition and examples. Okay. Next problem is give two examples of mutually exclusive events and exhaustive events and equally likely events. We have to give each event two examples. First, you can write mutually exclusive. Mutually exclusive. What is the meaning of mutually exclusive events? If two events having no common elements, that's why one die is throwing. One die is throwing. Sample space is what? Sample space is 1 comma 2 comma 3 comma 4 comma 5 comma 6. I am taking A is odd numbers. You can throwing the die odd numbers. You have to take A 1 comma 3 comma 5 is odd number. After that B is the even. But when die is throwing, bases are even numbers. What is the even numbers? 2, 4, 6 are even numbers. Then these two are mutually exclusive or not checked. These two are mutually exclusive or not. Here 1 comma 3 comma 5 intersection. A intersection B having compulsory pi. That's why these two are examples of mutually exclusive events. First example. Next example. You have to take second example. You have to take A is if one die is throwing, the selected number is odd number, nothing but 1 comma 3 comma 5. B is a even prime number. Which number? Even prime. Even prime number what here? Here only one even prime number is there, that is 2. Then A intersection B value is 5. This is also be one more example of mutually exclusive events. After that, next you goes to exhaustive events. Exhaustive. Next you goes to exhaustive events. In this exhaustive events, one die is throwing. Total sample space 1 comma 2 comma 3 comma 4 comma 5 comma 6. In this sample space, you have to take. In this sample space, we have to take A is 1. A is a 1 event. That A is you have to select bases are odd numbers. What is that? 1 comma 3 comma 5 is odd numbers. B is selected numbers is even. Even nothing but we have to take 2 comma 4 comma 6. Then A union B. A union B. 1 comma 2 comma 3 comma 4 comma 5 comma 6. That is A union B. 1 comma 2 comma 3 comma 4 comma 6. That value equal to 6. This is the mutually exhaustive events. Nothing but this value equal to sample space. This is one example. If you have to take A is any one event, you have to take 1 comma 2 comma 3 comma 4. A is the event. Next you have to take B event is 2 comma 3 comma 5 comma 6 B event. Then these two union, the combination of these two is 1 comma 2 comma 3 comma 4 comma 5 comma 6. 1 comma 2 comma 4 comma 5 comma 6 is a sample space. Then these two are examples of mutually exhaustive events. These two are mutually exclusive events. Only one experiment I can define, only one experiment, that is one die is rolled or one die is throwing. Next example. Next one is equally likely. Equally likely. In this equally likely event, you have to take first example. You have to take even numbers 2 comma 4 comma 6. After that we have to take B is odd numbers 1 comma 2 comma 3. This odd numbers. Then the number of elements of A and odd numbers is 1 comma 3 comma 5. The number of elements of A and B having equal. The number of elements of A and B are equal. That event are called mutually exhaustive event. Here n of A value is 3. Here n of B equal 3. That events are called mutually equally likely events. Which events? Equally likely events. This is also be called mutually exhaustive events. This is also be called mutually exclusive events. This example you can use 3 events. That is mutually exclusive, mutually exhaustive, and equally likely. Next one we have to take A is equal to 1 comma 3. You have to take A is equal to 1 comma 3 event. B is equal to 2 comma 3 is another event. B is equal to 2 comma 3 is the another event. Number of elements of A is 2. Number of elements of B also be 2. These two events having number of elements are equal. That events are called equally likely events. These are the examples of mutually exclusive, mutually exhaustive, and equally likely events. Today assignment problem or homework problem. In this previous problem model, give 2 examples of events that are neither equally likely nor exhaustive. What is the meaning of neither equally likely nor exhaustive? Neither equally likely nor exhaustive meaning that 2 events are not exhaustive events and not equally likely events. Suppose if 2 events are equally likely, the number of elements of these 2 events having equal, that is equally likely. Here not equally likely. That's why the number of elements of A and number of elements of B both are unequal. That is called not equally likely events. Next, what is the non-exhaustive events? Here, if events are exhaustive events, the combination of all events equal to sample space. Here, A comma B, both are the union of these two is not equal to sample space. That events are called not exhaustive events. Okay, students. Here, A number of elements of A and number of elements of B both are not equal. At a time, A union B both are combination is not equal sample space. That example you can try by using one die is rolled. One die is rolled or throwing one die. That example sample space is 1 comma 2 comma 3 comma 4 comma 6. This experiment you can use, you can try any 2 examples. First one is not equally likely, another one is not an exhaustive events. This is the exercise 6A completed. This is exercise 6A theory part. This problems coming to the IB examination, sometimes coming to the unexpected questions.